In this lecture, we are going to solve 7th numerical related to second order control system. The question is, a system has 30% overshoot and setting time 5 seconds for unit step input. Determine the transfer function and also calculate the peak time TP and output response. Assume the steady state error ESS at 2%. It is given in the question that the overshoot is 30%. That means the peak overshoot or maximum overshoot MP is given 30%. We know that the formula of MP is e to the power minus zeta pi divided by under root 1 minus zeta square. Now we put the value of MP here be equal to 0.30, which is equal to e to the power minus zeta pi divided by under root 1 minus zeta square. Now we apply natural log to both sides, then we'll get log 0.30 is equal to minus zeta pi divided by under root 1 minus zeta square. Log of 0.3 is equal to minus of 1.2030, which is equal to minus of zeta pi divided by under root 1 minus zeta square. Now we square both sides. Squaring both sides, we will get 1.45 is equal to zeta square pi square divided by 1 minus zeta square. This will be equal to 1.45 minus 1.45 zeta square is equal to zeta square pi square. When we solve this, we will get zeta square is equal to 0.1281 and zeta will be equal to 0.3578. This is the value of damping ratio zeta we are getting. It is given in the question that setting time is 5 seconds and we have to assume the steady state error at 2%. That means the setting time is taken at 2% tolerance basis. At 2% tolerance basis, the formula for setting time is 4 upon zeta omega n. Now from this equation, omega n will be equal to 4 divided by zeta into Ts. Now we put the value of zeta and Ts here. It will be equal to 4 divided by zeta is 0.3578 into setting time is 5 seconds. When we solve this, we will get the natural frequency of oscillations omega n is equal to 2.2353 radian per seconds. This is the value of omega n we are getting. Now we will find out the damped frequency of oscillations omega d. The formula for omega d is omega n into under root 1 minus zeta square. Now we put the value of omega n and zeta here. Omega n is 2.2353 into under root 1 minus 0.3578 whole square. When we solve this, we will get damped frequency of oscillation omega d is equal to 2.0873 radian per second. Now in this question, we have to find out peak time. We know the formula of peak time is pi upon omega d. Pi divided by omega d value is 2.0873. We will get 1.5051 seconds. So TP is 1.5051 seconds we are getting. Now we will find out the angle theta. The formula for angle theta is tan inverse under root 1 minus zeta square upon zeta. So we put the value of zeta here, we'll get tan inverse under root 1 minus 0.3578 square divided by 0.3578. When we solve this, we will get theta is equal to 69.03 degrees. We have to convert this value in radians. Theta in radians is equal to 69.03 into pi by 1/8. From here we will get 1.2048 radians. In this question, we have to determine transfer function also. Therefore, we know that the standard form of transfer function for second order control system is Cs by Rs is equal to omega n square divided by S square plus 2 zeta omega n s plus omega n square. So for this we have to find out omega n square. We know that omega n is equal to 2.2353 radian per second, and omega n square will be equal to 4.99. Now we have to find out 2 zeta omega n. 2 zeta omega n will be equal to 2 into 0.3578 into 2.2353. From here we will get 1.599. Now we put the values of omega n square and 2 zeta omega n in this equation. We will get Cs by Rs is equal to 4.99 divided by S square plus 1.599 S plus 4.99. So this is the equation of the required transfer function. Now lastly we have to determine the output response. We got the damping ratio zeta is equal to 0.3578. That means this zeta value is smaller than 1. So for zeta smaller than 1, the equation for output response Ct is given by 1 minus e to the power minus zeta omega nt divided by under root 1 minus zeta square into sine of omega dt plus theta. This theta will be in radians. We have to put in this equation. Now we put all the values in the equation. Therefore, Ct will be equal to 1 minus e to the power minus 0.3578 into 2.2353 t divided by under root 1 minus 0.3578 square into sine of omega d is 2.0873 t plus theta in radians we have to take. It is equal to 1.2048. When we solve this equation, we'll get output response Ct is equal to 1 minus 1.07 e to the power minus 0.8 t into sine of 2.0873 t plus 1.2048. So this is the required equation of the output response. So these are the values which we have found out in this numerical. Hope you have understood the numerical. Thank you very much for watching, and please do subscribe my channel for more updates.